The polynomial that I chose for my derivative project is 5x to the fourth power minus 7x to the third power minus x squared plus 5. I found the first derivative to be 20x to the third power minus 21x to the second power minus 2x. And I was able to find the extremes of the first derivative by setting it equal to 0, as can be seen by this section of my notes. I factored out an x from the first derivative, which let me have x is equal to 0 for 1, and for the other two I needed to use the quadratic formula, as you can see on the right. This gave me negative 0.08788 and 1.13788. Now, for the first derivative, it can be shown here that the three extremes are at different distances, but I was able to plug in numbers for the first derivative for both values that are higher and lower than the 3. Like the first one that I chose, which was negative 1, it gave me negative 39, meaning that it was a negative for the first derivative behind my first extremum. I then used negative 0.04 and got a positive, which means that the graph was decreasing from negative infinity to negative 0.08788, and then when I used 0.5, it was another negative, meaning that it went from positive to negative, which meant that it was increasing from negative 0.08788 to 0. And then I plugged in 2, which was positive. And that meant that from 0, going from 1.13788, it was decreasing from 0 to 1.13788. And from 1.13788 to infinity, it was increasing, as can be seen right here below the chart that I made for my three extremes. The relative max was at x is equal to 0, and the relative mins were at x is equal to negative 0.08788 and 1.13788. For the second derivative, I got 60x squared minus 42x minus 2, and I set it equal to 0 to find the points of inflection. And I got that it was at x equal to negative 0.04476 and 0.74476. For the chart on the second derivative for my f of x, it can be shown that I have the 2 points of inflection, and I had to plug in values that were higher and lower than the 2 points, like negative 1 being 100, 0 being negative 2, and 1 being 16. This meant that the concavity was up on the intervals of negative infinity to negative 0.04476 and 0.74476 to infinity, and the concavity was down from negative 0.04476 to 0.74476. And the limit as x approaches infinity for my polynomial was positive infinity. The limit of x approaches negative infinity. It's also a positive infinity because I have an even number as my exponent. And as can be seen here, I have my three extremes in my graph, and from the left it can be shown that it is going down. Now between these 2 points it's harder to tell zoomed out, but when zoomed in even more than they already are, it's shown that it is increasing. And from 0 it decreases and then increases once more.